very important topic related with tribology. How to make the measurement in modern tribology, the techniques, and from theory to practice. We have with us Professor Dr. Salish Pandey, who is the professor in the National Institute of Technology, Patna. Thank you very much, sir, for accepting our request and be ready for this lecture. Atulji, Dr. Dikshit Saab is there? Atulji Dikshit Saab. Atulji Dikshit Saab is there?
नो सर, अभी मैंने बात की थी बस फोन में पिक नहीं किया, फिर ट्राई करता हूँ
Okay.
एक बार.
Okay, thank you. So, Dr. Pandey
Sure.
started his journey after doing his BTech from in mechanical engineering, and he is a GATE qualified. His master's in mechanical engineering from DTU and MTech uh, and PhD work he did from DTU Delhi University. He is serving as training and placement officer at NIT Patna, where he guides and supports students in their career development, a position he has held since 2020. Sir, it is very good opportunity. We can also think to sign an MOU with you for having internship programs for your students in the field of.
Sure, sir. My pleasure. If I can support in any way to you, that will be my
Thank
pleasure,
you.
sir.
Thank you. Thank you very much, sir. It is my pleasure. We have signed this MOU with many. Thank you, sir.
My
Thank you.
pleasure, my pleasure. We are having the connect with around 10,000 companies, sir. And we
Very
can
good.
share the database also.
Sure, sir. Sure, we will do that, sir. He has a lot of experience of teaching in BTech, having doing the PhD work, research work. Sir, thank you very much for accepting our request and delivering a talk on this new topic, which is very important, tribology. I would request all the participants to be patient and heard from him what is the science behind it. We will take the questions after the seminar. Thank you very much. Over to you, sir. Thank you.
Thank you, respected Astos sir, for giving this opportunity to speak and interact with such a eminent audience. And I'll discuss about the metrological aspect and metrology in the tribology in sequential manner. But really, it's a great opportunity for me to interact with such a eminent scholar and such a eminent audience. Now, hope my PPT is visible to all.
Sir, it is visible, sir.
As we start thinking,
Please, sir.
we know about the measurement, and we know if we are not accurate in the measurement, that is very drastic, and we can have very catastrophic effect of the wrong measurement. If we talk about the measurement in the term of health, measurement in term of equipment that is being used for the surgery and all the medical equipment, that is very catastrophic. And similarly, if we are not able to do the measurement properly in any, if we are not able to do the proper measurement for the any mechanical component or any component, that is very catastrophic. We know how to do the measurement, that we are having a detailed knowledge of the theory, but we'll discuss about how we are practically implementing all these theoretical aspects in the practical life. And moving from very basics, how we can define the metrology. Metrology is the science of measurement, encompassing theoretical and practical aspect to ensure accuracy, precision, reliability. It plays a crucial role in industries from manufacturing and engineering to the healthcare and research. It's very crucial. If there is some error in the measurement in healthcare, then it will be dangerous for the health also, for life also. And in the research, if there is a very small deviation in the measurement, if we talk about the satellite launch and all these things, our trajectory will be different and will land to somewhere else. And metrology is defined differently based on its scope. The definition of the metrology can keep on changing depending upon their scope and their use and where we are implementing the metrology. Metrology is defined differently based on its scope and application. Here are the various definitions from different perspectives. We are having different perspective of the metrology. Generally, if we define the metrology, it is the science of measurement and its application. But if we talk about the scientific metrology, the branch of science that is concerned with the developing and maintaining standard of measurement and ensuring their accuracy and precision. This is scientific metrology. But if we talk about the industrial application and we'll start talking about the industrial metrology, the application of the metrology in the industrial industry. Am I audible, sir?
Yes, sir.
Okay, okay. Thank you, sir.
Sir,
Sir, if we talk about the industrial metrology, there is the practical implementation of the metrology in the field of industry. We are having different industries that is totally depend upon the metrology. And if we talk about the industrial metrology, that is the application and the measurement of science to manufacturing and industrial processes to ensure the product quality and compliance with the standards. And even in today's, if we talk about that, we are talking about the development and we are talking about the automation. We are talking about the artificial intelligence in the manufacturing. All we are implementing the new technology to ensure the accuracy in the measurement. If we are talking about the artificial in the measurement, that means that we are talking to increase the productivity with the accuracy. Here we are on the right side we have shown the different clause that is applicable for the metrology as per the ISO. And if we talk about the historical prospect of the metrology, if we talk about the historical prospect of the metrology is defined the study of the measurement principle and technique that have evolved over the time to establish universally accepted measurement system. If we talk about the legal metrology, the definition of the metrology is changing from use to use. We talk about the legal metrology, the part of metrology that deal with the regulation, standards, and law to ensure the fairness and reliability in trade, health, and safety. Now, if we talk about the applied metrology, the practical implementation of measurement technique across different industries, ensuring process control and quality assurance. Each definition emphasizes different aspects of the metrology depending upon its theoretical, practical, and regulatory importance. And we are, as per my knowledge, we are having 13 organizations that are totally associated within this legal metrology. And if we talk about the fundamental aspects of the metrology, these aspects are if we talk about the unit of measurement based on the internal system of SI, then we can talk about the traceability, how we can ensuring the measurement are linked to the national or international standard. Then we are having the calibration adjustment to maintain the measurement and accuracy and the accuracy versus precision. If we talk about the accuracy versus precision, if we talk about the accuracy versus precision, that means accuracy refer to the closeness to the true value, but precision denotes consistency in repeated measurement. And if we talk about the calibration is the adjustment of the instrument to maintain measurement in accuracy. And calibration technique and method that is depend upon the spanning, nulling, uh, linearization, and zeroing. We are having these aspects of the metrology. And if we talk about the standards of the measurement, We talk about the standards of the measurement standard and branches of the metrology. Standard can be a primary standard, secondary standard, and working standard. If we talk about the primary standard, that is about the reference standard, highest accuracy reference standard. If we talk about the secondary standard, that is the standard basically used for the laboratory purpose, and that is calibrated against the primary standard, and working standard that we are using in our daily life. Now we talk about the branches of the metrology, as we know, and we discussed about different branches of the metrology in the definition also. That is scientific metrology, industrial metrology, and legal metrology. We talk about the scientific metrology, deal with the establishment and maintenance of the fundamental measurement unit, and governed by the organization like International Bureau of Weight and Measure. We talk about the industrial metrology, ensure precision in manufacturing, engineering, and product quality. And calibration of the instrument, quality control, and process validation. If we talk about the legal metrology, that focuses on the regulatory and legal requirement for measurement in trade, health, and safety. This ensure the fairness in commercial transaction. And if we talk about the theoretical model, in this we have shown the theoretical model of the measurement. First, classical measurement theory, then statistical measurement theory, then quantum metrology. Classical measurement theory is totally based on physical standard and direct comparison. The example of classical measurement is length measured using ruler, time using clocks. If we talk about the statistical measurement theory, that uses probability in statistical model to analyze the measurement uncertainty. And the example of this, best example of this is Gaussian distribution of the measurement error. We talk about the quantum metrology, everybody is talking about the quantum, then quantum mechanics for ultra precise requirement, that is atomic clock and interferometry. And here dimension metrology, if we talk about the dimension metrology, that is used in the engineering and manufacturing, including the calipers, micrometers, coordinate measuring machines. And if we talk about the thermal and optical measurement, utilize infrared thermometer, spectrometer, and laser measurement system. Analytical and chemical metrology focuses on the composition analysis using chromatography, spectrometry, and mass spectrometry. If we talk about the mechanical measurement, involve the force and pressure measurement. If we talk about the electrical and electronic measurement, that is about the current and resistance, current resistance and voltage measurement. Now, we are going to talk about the measurement of wear through metrology. Before moving to this topic, what is the physical significance of the wear? What is the physical significance of the wear through metrology or friction in the metrology? All we know that it is not possible to survive without friction. And we always used to say in layman, the friction, we used to say in the layman language that घर्षण में ही आकर्षण है. If there is no friction, there is no entertainment in the life. So if there is no friction, we are not able to survive, and if there is no friction, we are not able to walk on the surface also. So friction is required, wear is required, but there should be some balance in the friction. Somewhere we have to increase the friction, somewhere we have to decrease the friction, somewhere wear is required to achieve the qualities, and somewhere we have to control the wear to achieve the our desired output. If we talk about the wear in the pencil, if there is no wear in the pencil, the use of the pencil is there is no use of the pencil if there is no wear in the pencil, because we are using the pencil to write because of its rubbing property and its wearing property. If there is no wear in the pencil, then it cannot be of any use. But if there is too much wear in the disc brake, then disc brake is of no use. If wear is in large amount, then we have to replace the disc brake again and again. Simply one example, if there is lots of wear in the engine, automobile engine, then it's very difficult to repair the engine and open and reassemble the engine. And that's why we talk about the engine, the quality of the engine is too good if it's working without opening. It means the wear in the engines is too precisely controlled, and we have to use a material in the engines which is having very less wear while working on the different condition. It has to work in the high temperature, it has to work in different working condition. Now, as I discussed, tribology is the science and engineering disciplines that deals of friction, wear, and lubrication of the interacting surface. I'm not going in detail of these, but this is tribology, and it encompasses the principle and mechanism governing the behavior of surface in contact. Let's deal with the friction, effect of the friction. If two bodies in relative motion, all these come automatically come into the existence. If there is two bodies that are into relative motion, then friction will come, lubrication is required, and if there is no lubrication, we have to deal of some solid replication also, wear on the performance and longevity of the mechanical component and system. If the two body in the relative motion, we have to deal with all these factors. And if we talk about the significance of the tribology, because of the development and lots of research and development in the tribology and coating, these automobile and aero turbine is now we are flying from one country to other country, one continent to other continent. This is all because of advancement of technology in the wear, coating, and friction. If we talk about the energy efficiency, we have achieved the energy efficiency because we have developed the technologies to reduce the friction and reduce the wear up to a optimum condition till now, so that we are getting highest energy efficiency in different application. Even the friction and wear is too much control in the automobile engine that we are able to achieve the efficiency up to around 30 to 33%. We are working on it to achieve it more about 50%, but as per current research, we are up to 33-34%. And if we are able to control the wear, then we are able to control the micro particle into the environment and the different gases that are being oxidized because of higher temperature. If we are able to control the friction, wear, we can improve the life of any working component, as well as we can increase the uh, living condition for our upcoming generation. And uh, this is going to impact if there is too much of loss because of friction and wear, we have to replace the component again and again. That is the extra burden on any industries. This is the extra burden for any customer. From customer, this is burden for the industries. From industry, this is burden for the country. And if we are able to control the wear and friction, we are contributing to country in the positive manner, and we are contributing to the economic growth of the country. Tribological metrology, which is basically involve the measurement and characterization of surface and their interaction under various tribological condition. If we talk about the tribological metrology, then in the tribological metrology, we are having friction. Then we are having wear, and we are having lubrication. In the tribological metrology, we are having the measurement of wear and how we can control the wear and how we can characterize the wear, and their surface topography is also in the tribological metrology of this. Then quantification of friction and wear and surface topography analysis. It allows the precise measurement. If we talk about the quantification of friction and wear, it allows the precise measurement of the frictional forces and wear rate between two bodies that are in the relative motion. If we talk about the surface topography analysis, tribological metrology enable the detailed analysis of surface topography, including roughness, texture, feature, expertise, etc. And thick film measurement, whether the lubricant film thickness measurement is also part of the tribological metrology. This information is essential for evaluating the effectiveness of the lubricant in reducing friction and preventing direct metal to metal contact, thereby minimizing the wear and investigating the contact mechanism. And further, if we are able to investigate the contact mechanism, we can investigate which type of wear is occurring in the surface and which mechanism, whether it is abrasive, adhesive, uh, or erosive, which type of wear mechanism is happening, and depending upon the wear mechanism, because every wear mechanism is related and correlated with the type of force that is impacting the surface, we can control the wear. Characterization of the surface chemistry. This is also a part of tribological metrology. Surface chemistry influences the adhesion, friction, and wear behavior of the material, making it critical for understanding and controlling surface interaction. Evaluation of the tribofilm and surface modification. Tribological metrology technique are used to characterize tribofilm form on the sliding surface as well as surface modifications such as coating, treatment, and texture. And these days, lots of researchers are working on the coating because it is not possible to manufacture the tailor-made material for every application, because manufacturing a tailor-made material for every application is very costly. And if we are manufacturing a tailor-made material for every application, that it will be very difficult, and that will not be economical for industrial application. If that will not be economical for any industrialization, then we have to search for the alternate with the help of which we can do the tailoring of the properties in the material. That alternate, that organization industries are opting this time, that is to coating. And with the help of coating, this is a branch of additive manufacturing. Coating is the branch of additive manufacturing, and with the help of coating, we are able to develop uh, surface that is tailor-made, and the property which we are requiring, we can do the coating with the material. As if we want to increase the hardness, if we want to increase the uh, uh, temperature resistance property, then thermal barrier coating is there. If you want to increase the hardness, there are lots of oxide with the help of which we can do the coating. And if you want, even if you want to protect the surface with the moisture and all these, then we are having different type of hydrophobic coating also. So coating is lots of researchers are working in this field, and this is very important. Validation of the computational model. Tribological metrology provide experimental data for validating computational model and simulation of the surface interaction. We are talking about the tribological metrology. We are talking about the tribological metrology, and tribology comes in the picture. If there is no friction, there is no discussion of the tribology. And if we are discussing about the tribology, it means there is friction. And friction, we can classify the friction in two parts, as static friction and kinetic friction. The static friction refer to the frictional force that prevent an object from moving when its external force is applied to it but hasn't exceeded the maximum force of the static friction. This is a schematic diagram of static friction. Kinetic friction, also known as the dynamic friction, comes into the play when two surfaces are already in motion or in relative to each other. And in the tribological part, we have to deal with this kinetic friction because we are maximum at maximum point we are dealing with the relative motion. Both type of friction are influenced by nature of the surface in contact and the magnitude of the force that is pressing each other. Now, we'll discuss brief about the different type of equipment that is being used for the characterization being used for the characterization of these friction. First, we talk about the tribometer. Basically, tribometer is equipment that is used to calculate the wear, friction, and patterns of the wear on any relative body. In this, we are having two bodies. One is the object, and other is the counter body. And if object and counter body are in relative motion, with the help of sensor, with the help of different mechanism. And the most prominent mechanism is the weight loss mechanism, with the help of which we can collect the weight loss, that is weight loss, wear in term of weight loss. In this, we have to collect the data of the weight loss by measuring the substrate before putting for the experiment and after completing the experiment. And then we can measure the weight loss with a precise equipment, and we can get the wear of the surface. And then by analyzing the depth, analyzing the track depth, analyzing the track, we can get which type of wear mechanism is occurring. Depending upon the interaction of the bodies from surface to counter body, this pin on disc, this tribometer can be classified as pin on disc tribometer, block on ring dash tribometer, or ball on flat setup tribometer. We are having different type of tribometer in our lab at NIT Patna. We are having pin on disc tribometer. If anybody interested to doing the research on the pin on disc tribometer, we welcome them, and we provide them all type of facility. Now, after this friction analysis, if we have to analyze the surface, then we can choose the atomic force microscope, and with the help of atomic force microscope we can measure the friction also, and we can measure the surface topographies also. AFM can be used to measure the friction at nano scale. This AFM, this is very important. We are using the atomic force microscope because its probe is a very small size and its accuracy is very high. That's why we are using this for the nano scale friction measurement. By scanning the sharp probe tip across the surface and measuring the force experienced by the tip as it interacts with the surface. AFM can provide detailed information about the surface topography, addition, frictional properties, and that too with high resolution. On the right side, we have shown the pictures of tribometer. The first one is the pin on disc tribometer, and the second one is the atomic force microscope. Instead of this pin on disc tribometer, we are having the friction tester. We are having bench top testing machine also. And importance of friction measurement in material selection and design. What is the importance of friction measurement? What is the importance of friction measurement in material science and design? First, we can do the performance optimization, and we can do the friction and wear prediction for the prevention. We can do prediction of the wear, prediction of the failure, prediction of the friction, so that we can forecast the approximate working time of any equipment. If we talk about the performance optimization, friction directly affect the performance of the mechanical system. By accurately measuring friction coefficient between different material, engineers can select the most suitable material and surface treatment to optimize performance, efficiently, and reliability. If we talk about the wear prediction and prevention, friction measurement help in the predicting and preventing wear of mechanical component by minimizing wear and extending the lifespan of critical component, reducing maintenance cost and downtime. If we are somehow we are able to forecast the exact time of the wear prediction, then we can reduce the downtime. And if we are able to reduce the downtime, the efficiency and productivity can be increased. And if we are able to analyze the uh, friction and wear property, then we can select the material for a specific application. Because we are selecting, sometime we need to select the material for the higher temperature application. If we are sending any spacecraft, or we are sending any uh, spacecraft on the space, then we have to choose a material that can work from minus temperature to plus temperature. And generally it is minus 50 temperature to minus plus 150 temperature. There is lots of variation, and depending upon the knowledge of the friction, wear, and properties of the material at different temperature, we can select the material for the specific application. And if we are selecting the material for the turbine, that the property is something different. If we are choosing the material for the pencil, that properties are different. If we are choosing the material for the disc brake, the properties are different. If we are choosing the material for steering, automobile crankshaft, automobile engine, automobile piston, then properties are different. If we are having the accurate knowledge of the friction and wear measurement, they can allow the engineers to tailor material selection based on the application requirements, such as low friction for high speed bearing and high friction for braking system, or control friction for clutch assemblies. That totally dependent upon the knowledge of the friction. And by comparing experimental result and theoretical prediction, engineer can improve the accuracy, reliability of the simulated model, leading to better informed material selection and design. Overall, all friction measurement is essential for guiding material selection, optimizing design parameter, improving performance, ensuring safety, reducing cost in various engineering applications. Now, we are talking about the friction, we are talking about the wear, we are talking about the selection of the material depending upon previous knowledge of the friction and wear. Here, it's very important to discuss different type of wear mechanism and why these type of wear mechanism are happening. First is the abrasive wear mechanism, and second one is the adhesive wear mechanism. Then we are having erosive wear mechanism, abrasion is there, erosion is there, scratching is there. All these are the wear mechanism. But let's discuss about the abrasive wear mechanism. If two material that is coming in contact with each other, and one is the hard material and another one is the soft material. If hard material is coming in contact with the soft material, what will happen? The hard material pull off some of its part from the soft material. Hard material will take some of its material from the soft material. This is known as the abrasive wear, and lots of abrasions, lots of expertise will be there, lots of scratch will be there on the surface, and you can get the clear visible mark on the surface of soft material. You can get the picture of lining, picture of erosion on the surface of soft material. Abrasive wear occur when hard particle or abrasive particle repeatedly contact and remove material from a softer surface. This type of wear is common in application involving the presence of abrasive contaminant or sliding against rough surface. When any body is sliding against rough surface or any uh, hard material is rubbing on the soft material, then this type of wear is often. And if we talk about the piston and cylinder motion, then this type of wear is very predominant. This type of wear is dominating in if we talk about the piston and cylinder movement. If we talk about the adhesive wear, this this is as its name suggests, this adhesion. If some material that is pulled off or that is detached from the surface and attaching to other surface known as the adhesive wear, this typically happen under high contact pressure or insufficient lubrication condition, leading to localized surface damage and material transfer. Adhesive wear often result in surface scoring, seizure, and component failure. If there is lack of lubrication or if the particle is temporarily getting welded into the other part, this is known as the adhesive wear. That is because of lack of lubrication or a localized uh, surface damage or material transfer that is happening from one part to other part. Erosion is very, if we talk about the erosion failure, that is catastrophic failure for any equipment. Erosion wear is caused by the impact of solid particle or fluid droplet on a surface, leading to material removal through a repeated impact and erosion. This type of wear is common in application involving high velocity flow of the abrasive media. And this erosive wear is dominant where the velocity, uh, where the air particle or some fluid particle or some material is moving with a high speed and interacting with the surface that is being used. If we talk about the erosive wear is very dominant wear mechanism. We talk about the turbines. But if turbines are not better controlled and not better protected with the help of protecting material, then erosive wear is very dominant in the case of turbine blades for the aircraft and jet engine. Everybody know about the corrosive wear. If any material is not properly protected and that is in touch with the atmosphere, then oxidation of the surface, while there is little increase of the temperature, then oxidation of the surface will happen, and because of oxidation, the material get corroded. Corrosive wear occurs when combination of mechanical action and chemical action lead to the degradation of the material on the surface. Corrosive wear is prevalent in environment containing corrosive fluid or gases such as acid, alkali, and salt water. Fatigue wear results from repeated cyclic loading and unloading of a material, leading to the formation of crack and eventual material failure. Fatigue wear Fatigue wear is basically fatigue wear occurs at the interface between two surfaces under the slight relative motion, typically induced by vibration and oscillation. Understanding the mechanism and characteristic of different types of wear is essential for selecting appropriate material, appropriate lubricant, and surface treatment to mitigate the wear. And if we are somehow able to mitigate the wear, then we can improve the reliability and longevity of any mechanical component. How we can measure the wear? We know we have to control the wear, but without knowledge, without measurement of wear, we cannot do anything. So, either we can measure the wear with the help of weight loss method, that is measuring the weight before the experiment and after the experiment. But for that we need very accurate measuring weighing machine, very accurate weighing machine, and this is very cumbersome process to measure the material before the experiment and after the experiment, and there is some loss of the material in the environment also. So we cannot think that measuring weighing the material before the experiment and after the experiment is worth it. But in most of the lab, we are measuring the wear with the help of weight loss method. But if we are having the facilities of profilometer, the profilometer is the best. We are measuring the wear of the any surface with the help of profilometer. In the profilometer, we are taking the picture of the surface. We are taking the profile of the surface before the experiment and after the experiment, and with the help of overlapping techniques, we are getting the loss of the material. Profilometry involves measuring the surface topography and change in the surface roughness caused by wear. A profilometer is measuring instrument used to measure the surface profile to qualify its roughness. Critical dimension as step, curvature, and flatness are captured from the surface topography. We can do the wear scar analysis also. Wear scar analysis involves the measuring the dimension and characteristic of the wear scars found on the surface due to wear. This can be done using optical microscope or scanning electron microscope to quantify parameters such as wear scar diameter, shape, size, and area of the distribution. Wear scar analysis is particularly useful for assessing adhesive wear, abrasive wear, and erosive wear. Here, you can see this is not scanning electron microscope micrographs of wear scars, but this simple SEM diagram. Optical microscope are used to examine wear track and surface feature at different magnification. This method help in identifying wear mechanisms such as abrasion, adhesion, and fatigue based on the surface morphology. Now, this is very important equipment for analyzing the surface morphology. Scanning electron microscope and atomic force microscope. This is very useful, and this is heart of any material characterization or surface topography. And this offer high resolution imaging of bare surface, allowing for detailed examination of the bare features such as cracks, pits, or material transfer. Energy dispersive spectroscopy can be coupled with SEM to analyze the elemental composition of bare debris. This is micrograph that is taken from the scanning electron microscope, and this is picture of the one of my coating surface. And if we want to measure the topography on the nanoscale, then we have to use the atomic force microscope. This atomic force microscope is costly in comparison to the scanning electron microscope, but this provides the nanoscale resolution of the surface topography, allowing the precise measurement of bare induced surface changes at the atomic level. This technique is particularly useful for studying bare in thin film or nanometer. Micro hardness testing basically used to uh, measure the surface properties before the, if we talk about in term of wear, we are measuring the micro hardness of the surface before the wear test and after the wear test, and we are analyzing whether what is happening, whether hardness of the material is increasing or decreasing depending upon the increase or decrease of the micro hardness. We have to predict which type of wear is there, how much the temperature is there, and such Vicar or noob testing hardness are performed on the wear track to assess the change in the material hardness due to wear. This technique help in understanding the material property alteration induced by the wear process. We are talking about the induced by the wear process. We are talking about the temperature that occurred during the process of the beer. Lubrication plays very crucial role wherever we are using the lubrication. Lubrication plays a very crucial role in the beer mechanism. This is used for the friction reduction, wear prevention, and the most important role of this lubrication is also the distribution of the load on the surface. If they are distributing the load on the surface properly, then wear will be reduced. And they used to control the temperature. This is for the corrosion protection also. This is for the sealing and contamination control. And this is for the enhanced performance also. How we can do the film thickness measurement of this lubrication? Optical interferometry is there, ultrasonic interferometry is there, and electrical capacitance measurement is there. How we can analyze the performance of the lubrication? We can analyze the performance of the lubrication with the help of boundary lubrication analysis. For this, we are having 4-ball tester, Pinandis tester, and strike back curve analysis tester. We are having different type of boundary layer lubrication techniques with the help of which we can analyze the lubricant performance. If in this test, Pinandis, if we talk about the Pinandis tester that is being basically used in laboratories, and strike back curve is the analysis that generally used in different applications. Now, if we talk about the chemical analysis for the viscometers, various type of viscometers such as rotational viscometer, capillary viscometer, and falling ball viscometer are used to measure the viscosity of the lubricant at different wear rates and temperature. Viscosity is a critical parameter influencing lubricant performance and film formation. Then we are having FTIR spectroscopy that is basically used to analyze the chemical composition of the lubricant and identify the degradation product. Changes in the lubrication chemistry over time can impact the performance of the lubricant life. This is very important. We have to control the composition. If there is degradation, if there is change in the component in the lubrication, it means the proper lubricant is losing its property. And with the help of FTIR, we can characterize the material, we can study the molecular interaction, and we can do the quality control of this lubricant. Atomic absorption spectroscopy, then importance of why we are talking about different measurement technique, different metrological technique. We are talking and we are reading all these techniques so that we can reduce the friction and wear, improve the efficiency, and prevent the component fault failure. We are having these 3 targets: reducing friction and wear, improving efficiency, and preventing component failure. And additionally, we can do the enhanced reliability if we are increasing and we are having the better control over the friction and wear, then we can improve the reliability, we can mitigate the contamination, we can optimize the lubricant selection. Now, we are coming to another metrological aspect, that is the metrology of the surface roughness. And we can do the metrology of the surface roughness either with the help of scanning electron microscope or with the help of atomic force microscope. Also, we can do uh, the surface roughness measurement with the help of Taylor-Hobson telescope. Surface roughness analysis is a process of quantifying the deviation in the surface texture of a material at microscopic and microscopic level. This analysis provides valuable information about the surface quality, finish, and topography, which are critical for various industrial applications. Surface roughness analysis involves several techniques and parameters to characterize the surface irregularities accurately. Here, on right side, we have shown the AFM image of any surface. With the help of this, we can characterize the surface in complete manner. How is the peak, how things are varying. With the help of contact profilometry, also we can do the surface analysis, involve physical scanning a stylus or probe across the surface and measuring the vertical displacement to determine surface roughness. Common contact profilometer include a stylus profilometer and atomic force. If we talk about the non-contact profilometer, utilize optical and laser-based method to measure measure surface roughness. Without physically touching the surface, technique include optical interferometry, focal microscopy, and laser scanning confocal microscopy. 3D surface metrology capture three-dimensional surface profile to analyze surface roughness in detail. Technique include white light interferometry, coherence scanning interferometry, and focus variation microscopy. We talk about the friction. Friction is basically depend upon three factors that can be classified with the classification of three aspects. One is the contact area, second one is the interlocking and adhesion, then third one is the hysteresis and energy dissipation. Rough surface have more contact point and asperity resulting in a larger real area of contact compared to the smoother surface. This increased contact area lead to the higher interfacial adhesion forces and frictional resistance during sliding and rolling. Asperity on the rough surface can interlock to adhere to each other, generating higher frictional forces. The adhesion mechanism contribute to the elevated friction coefficient, especially under boundary lubrication condition where direct metal to metal contact occurs. If we talk about the hysteresis and energy dissipation, surface roughness introduce irregularity in the contact surface, leading to hysteresis losses as the surface deform and recover during sliding. This energy dissipation contributes to overall frictional resistance experiencing by contacting surface. Now we have discussed this. Lubrication we have discussed this. Contact profilometer we have discussed this. We have discussed this. These are the equipment that we are having in our laboratory. If anybody interested in doing test on these equipment that we are having the pygmometer for the density measurement, we are having the XRD, we are having the FESEM, we are having the ion sputtering lab. Here in our we are having the Raman spectrometry and we are having the indentation instrument. If anybody would like to work on these equipment, he can contact me anytime. Significance of surface roughness analysis along with the friction and wear. What is the significance? Why we are doing the surface roughness analysis in so detail? Surface roughness quantification is basically the quantification of the contact area. Then with the help of this we can do identification of the wear mechanism. We can do the prediction of frictional behavior also. Understanding of the lubrication effect, optimization of the surface test treatment, and validation of the wear model. Now we have shown a case study. This is part of our research publication measuring the wear behavior of aluminum reinforced GNP and nanodiamond. We have prepared a coating that is alumina reinforced graphene nanopowder and nanodiamond. In this, we have performed the pin on disk triometrical test on the surface and For the performance of the test, the parameter was 10 Newton, 15 Newton, and 20 Newton. The sliding velocity was 0.156 meter per second, and speed was around 250 RPM. And basically, we are performing this case study for automobile application, and based on the different literature review, the load that can be applied on the automobile component, that is, if we talk about the automobile component, we are talking about the engine part, that is for the piston and cylinder movement, that can be around 10, 15 or 20 Newton. So we are taking this, and sliding speed and RPM, we are taking the constant. In this, we have considered the counter body as a ball of disc, and the diameter of the counter body is around 6 millimeter. Tungsten carbide with similar for all tests. And disc, we have taken disc, different type of disc with different type of coating. Disc is of 60 millimeter of diameter and thickness of 2 millimeter of mild steel with composite coating of Al2O3, and Al2O3 mixed with 0.1% by weight of nano diamond, then Al2O3 mixed with by weight of 1% nano diamond and 1%, 0.1% nano diamond and 1% of graphene nanoparticles. And the condition of this test we have considered this test as a dry test condition. We are not considering this on the lubricating condition. Then here we have shown the different here weight loss, as we are adding the coating that we are having with aluminum oxide, then aluminum oxide with the added with the graphene, then aluminum oxide with addition with the nano diamond and graphene nanoparticle. The weight loss keeps on decreasing. Weight loss keeps on decreasing on 10 Newton, 15 Newton, and 20 Newton, and all the weight. Even with the increase of weight, the weight loss keeps on decreasing with the addition of nano diamond and graphene nanoparticle. Here, the beer weight loss and beer weight loss of alumina standard is highest, and the lowest value obtained when we have added the aluminum oxide along with the nano diamond and graphene nanoparticle, when all the coating is processed through tungsten carbide body during the test. All results are obtained due to the formation of several films from the counterpart, improved classification and resilient boundary between ASD, AND and ANDGSD. Here, this is graph we have collected from the Fernandez tribometer, and this graph clearly shows the variation of the coefficient of friction with time and at different loading condition. The first one is at the loading condition of 10 Newton, then 15 Newton, then 20 Newton, and then in the last we have shown all the coefficient of friction on same load. Here the coefficient of friction is as we have demarcated with different type of color: ASD, ANDSD, ANDGSD. That is aluminum oxide with the nano diamond powder, then aluminum oxide with the nano diamond and graphene nano powder. And we have found that if we have added graphene nano powder and aluminum oxide on the composition, then our coefficient of friction reduced, and with the reduce of the coefficient of friction, the weight loss is also reducing. The finding of this research was coefficient of friction does not show the momentous change by adding 0.1% weight of nanodiamond in Al2O3 matrix due to inadequate formation of solid lubricant at the interaction surface. So, if we are adding 1% by weight of GNP in Al2O3 has shown significant decrease in the coefficient of friction compared to the other sample because of self-lubricating property of the graphene nanopowder. this is SEM image of the wound surface, with the help of which we can analyze different wound surface of the coating. Here EDX of the sample. Now we can go for the second case study also similarly. This is surface scanning electron microscope of the surface coated with the help of plasma sphere coating technique that is available at the IIT Patna. If anybody want to do the surface modification or surface coating with thermal sphere coating, he can drop me a text or mail. I'll arrange the slot at the IIT Patna and can do coating. Here we are having different scanning electron micrograph of the coatings. We are having the composite coating that is developed with the help of MO. This is composite coating. We are having molybdenum powder, NiCr powder, tungsten carbide powder, and tungsten mixed together. We again use the Pinandic thermometer for the application, but here the variation in the temperature and load both are there, and the experiment was very exhaustive. We have performed about a study on around 180 samples to find out the result. The test one was at 100 degrees centigrade. Second one was at 200 degrees centigrade. Then third 300 centigrade. Then at 400 centigrade. Similarly, the speed was 1.5, 2, and 2.5. This sample also we have taken the counter body of EN31 and disc of 2 millimeter thickness made of mild steel with the composite coating of WWC, MO, and NiCr. Here in this image, you can show the scratch abrasive wear clearly worn out surface on the surface in the SEM scanning electron microscope. On right side, you can get the pin on disc image, image of the beer patterns with the pin on disc machines, and the weight loss that is decreasing with the increase of temperature, and the micro hardness that is increasing with the increase of temperature. And this micro hardness can also be seen with the help of dewiring, and with the help of dewiring, the residual stress is decreasing with the increase of temperature. It means while we are increasing the temperature, the stress relieving process is happening. Now researcher are started talking about the nano tribology and surface engineering and in situ real-time monitoring, but we have not worked on this till now. Advanced material and coating, uh, we are having different trend and challenges for this. Then we can go for the green tribology and sustainability. Everybody and almost all the industries are working on green tribology and sustainability. This is basically emphasis on the green tribology principle, focusing on the sustainable lubricant, renewable materials, and environmental friendly manufacturing process to minimize energy consumption and environmental impact. The challenges of green tribology is balancing the trade-off between environmental sustainability and tribology performance, such as reducing friction and wear without compromising the material compatibility. That is very difficult. Then we are moving to Industry 4.0 and digitization. Integration of tribological metrology into Industry 4.0 framework, leveraging digitalization, automation, and data analytics for predictive maintenance, condition monitoring, and optimization of the manufacturing process. Ensuring data challenges of Industry 4.0 and digitalization is ensuring data interoperability, security, and standardization across heterogeneous tribological measurement system and industrial platform to enable seamless integration and actionable insight. Thank you, Agrawal sir, for giving this opportunity to speak in front of such a eminent audience. And I request all the audience, if you need any support from my side in the tribological characterization. We are having very excellent lab that is established in Patna, and we all are working. Here we are working in the collaboration with the IIT Patna, and we are having almost all type of setup that is available here. If anybody want to work on tribology or want to do any quoting, he can contact me. He can drop a text. He can mail me. I will be very happy to support. Thank you. Thank you very much. Thank you very much for petitioning.
Thank you. Thank you very much, sir, for your brief and wonderful presentation.
Sir, am
Thank
I
you very much,
audible?
sir, for wonderful presentation. Thank you. I would like to request Atulji and Ronak, please
Yes,
bring
sir.
the all participants,
Yes, sir.
panelists, so that we can take the photographs.
Yes, sir.
And kindly remove this slide presentation so that we can take the photographs, please.
Sir.
बाकी